Hello, my name is Elif Keskin. I'm a first-year industrial engineering student at Bilkent University. And this is my Physics 102 lab project video. In this video, I will be studying how the configuration of resistors affect current and power. I will be observing the relations in both in a series connected circuit and in a parallel connected circuit. For this experiment, I need 5 identical resistors, a 10-volt voltage source, a multimeter to measure the equivalent resistance and also the current, and some connecting cables. First, I started with measuring the identical resistors' resistances by connecting them to a multimeter, which was adjusted to measure resistance. I connected one identical resistor in series at a time and found the equivalent resistance values. Then I set a circuit with one resistor connected to a multimeter and a 10-volt voltage supplier. I measured the resistor's current and continued adding the other resistors in series one by one, meanwhile measuring their currents every time I add another resistor. I wrote down the experimental data to the table and sketched a current resistance graph to observe the relation between current and the number of series connected resistors. Then I calculated the theoretical current values by using Ohm's law and compared the middle terms to find the error. The error was 0% because the theoretical and experimental middle current values were exactly the same. After that, I calculated the power values with this formula and sketched the power resistance graph. I observed from the measurements and the graphs that as the number of series connected resistors increases, the equivalent resistors is also increases, but the current decreases. So there's a inversely proportion between current and the number of resistors in a series connected circuit. Similarly, the relation between power and resistance is the same. As the number of resistors in series in a circuit increases, the power decreases, and there is again an inversely proportion between them. For the second part of my experiment, I did the exactly same things for a parallel connected circuit. I measured the equivalent resistance of the resistors, connecting them one by one in parallel. I set a parallel connected circuit and added another resistor at a time in parallel, meanwhile calculating the currents of each circuit. I sketched this current resistance graph with the experimental data that I have. Then I computed the theoretical values of current in a parallel connected circuit, again using Ohm's law, and compared the middle value with the experimental one. I found error as 0.6%, which is again a really small number. The reason of the error may be due to environmental conditions and some human errors. Finally, I computed the power values by using the voltage and the total resistance and sketched the power resistance graph. From the second part of my experiment, I observed that in a parallel connected circuit, as the number of resistors increases, the equivalent resistance decreases, so the current increases. and therefore there is a direct proportion between the number of resistors and the current in a parallel connected circuit. And again, the power acts like the same. It increases as the number of parallel connected resistors increase in a circuit. And therefore, again, there is a direct proportion between power and the number of parallel connected resistors.